Hello everyone and welcome back to the channel. In this video we have a repair from a LG air conditioner multi-unit. It is a 58,000 BTU that can be connected with many splits inside. This is the main PCB assembly. The customer has replaced this PCB with a working one, so he wanted to repair this one just to have it as a spare. As you can see, this board may be common among many models, so the repair and methodology may apply to other ones as well. Let's get started. We can already see that the fuse is missing. Power comes in through this connector here. We are glowing. So what we've got, we have the live and one phase, neutral, and R, which is another phase. This is a three-phase unit. Let's check to see what happens in the input. So we've got our live coming in here, goes through the fuse and back all around here with some more passive components, and goes in this common mode choke. Neutral as well, goes from the other side. Oh no, goes from here, as you can see, straight to one leg, and those two go to the bridge rectifier and an NTC inrush limiting part, so that the capacitor doesn't get charged up very quickly. And then we have this black box that it is connected, one piece here with one pin of the capacitor, the main capacitor, and the other one, as you can see here. Let's take out our multimeter and check. Maybe is it better like this? So first of all, we need to check if the fuse was blown, and for that we will need to check between live and neutral. Oh, as you can see, 1.34 ohms. We definitely have a short circuit. Let's check. So the input of the bridge rectifier is dead short. Output, same here. So now we need to start desoldering and removing parts and find out where is the short. We'll start from the bridge rectifier, then the main filter capacitor, and then we will have to remove this DC converter or whatever it is. The desoldering station is getting heated up. I forgot to say, model number for this is EBR 37855616. and that's the code on the box as well. Now our desoldering station is ready. Let's remove the bridge rectifier. I will add some solder to help it. I will also desolder the capacitor, and that will give us a bit of space as well. We need to check it anyway. As we can see, these boards have all the markings, so we don't need to worry about orientation. We can find it later. Minus is here. Let's see if our bridge rectifier is gonna, oops, so no, it's not, this one is not desoldered. There we go. So now let's check again our AC input here, and yes, the short is gone, although 50k is a bit low. And let's check our other side, and sure enough, the short is gone here as well. No problems here. I want to just check those two diodes. Those look fine. And finally, I want to remove the power module because I have bought a replacement, just to compare it with the other one and see if there are any problems there. I'm just checking if any pins are moving, and there we go. It has some labeling, but it is just pin numbers here. So the input is these outside pins. The other two are not used, as you can see. And in diode mode, nothing. Here so those are two separate pins, so they shouldn't be sorted, I think. Let's check here as well. Here is the replacement part. It has the same sticker on it, and let's see now if it measures the same. So both outside pins, same thing, about 30 milliohms. Same thing here. Okay, so this does look the same actually. Just a bit of a difference. Let's see the other ones as well. So maybe I was in diode mode. These two pins the same. So I think I'm going to use the original one with a lamp for current limiting, so if anything is shorted we won't do any more damage. I am a bit skeptical about these two pins of the power supply. As we can see here, where's my stick? They are labeled GND2 and 1552. So we should somehow get 15 volts from there, but it is very unlikely with such low resistance. I cannot think of anything else, just to give it a try. So just to see that the bridge rectifier was the problem here. Dead short there. Come on. Same almost on the other side. Although this could be because of this sorting out, I don't know. Let's give our capacitor a test. Capacitor measures absolutely fine. Unfortunately, I bought the SMD replacement part for the bridge rectifier. I'm going to use a different one I had. It's the DF10M. It's a 1000 volt 1 amp bridge rectifier, so it should be just fine. Be careful for of the orientation. And yes, it's in there. Let's solder that. Nice. Let's solder the power module. I didn't notice before, but the middle pin here of the 15 volts rail, it's not used in other side. Let's put our main filter capacitor in, minding the orientation, and we will have to hold this up with the other hand. We can always solder one pin and put it all the way through the board. We are ready for test. I am a bit skeptical about this and how it will work. I will need a connector for here, and I think I'm gonna use this one. If I cut this, yeah, that will work. I have actually soldered the test lamp through the fuse, so if this thing lights up brightly, we have a short definitely. How I'm going to do this? We won't use the earth at the moment. I cannot stress enough that working with mains voltage is dangerous, and care must be taken. So let's fire this up. So it does seem to work. We definitely need to measure the secondary 15 volt rail. Just out of curiosity, take a temperature of the power module. It looks absolutely fine. I'm going to cut the power. Now I have removed the lamp and installed the proper fuse, 3.15 amps, and I just want to take a couple of measurements. Stay there. I will power it up and take two measurements from the 15 volt rail. One would be here, there, and the other one there. Let's fire it up. It is live now. Be extremely careful. This is the hot side. $15 volts there, everything okay. It's the GNT2 with the 15 volts one, and let's check the 15 volts 2 here and here. We only get 4.8. So I don't know if there is something else that needs to be connected here or is missing. Just take from 2 more points, like here. So it is a bit different here. No, 5.2. So I don't really know. We'll cut the power now. Just to flip it. And again you can see that all the diagnostic LEDs are operating. So the second 15 volt rail we were measuring goes here, where there is nothing at all really. I don't know how that works, but the PCB looks that it is operational. So that was it for today. I hope you found this video interesting. Subscribe if you enjoy this content, and I will see you on the next one. Thank you for watching. Bye.